before getting into the remaining 5 of the 7 basic quality tools, I'd like to briefly talk about their history and where they call home. Do these tools have parents? Well, I wouldn't say mother and father, but rather grandfather and father. And you know them both by now. W. Edwards Deming became the grandfather based on his repeated mentioning of the basic tools within his courses on statistical process control. And the actual creator was none other than Kaoru Ishikawa. I'm sure it won't surprise you when I mention that these tools have numerous homes, and again, it probably won't surprise you when I mention that one of them is lean manufacturing, or the Toyota production system. The other habitat for these tools is Six Sigma. So contrary to popular belief, Six Sigma was not born in Japan, but actually came from Motorola in 1986. That being said, I do believe that TPS had a very strong influence on Six Sigma. One example is the use of the DMAC, which stands for Define, Measure, Analyze, Improve, and Control. So do you see a similarity to the Deming cycle? So why is it called Six Sigma anyways? 99.99966% of the products produced are statistically expected to be free of defects, 3.4 defective parts per million. Enough with the introduction. Let's take a look at the tools. First one is check sheets. This tool is sometimes also referred to as a tally sheet or a checklist, but the intention is to organize facts in a manner that will help in identifying potential quality issue. The chart is useful for both quantitative and qualitative data. Companies also often use a control chart when it comes to quality improvement. This chart is used for monitoring and ensures statistical control. So the next one is Pareto diagrams. The Pareto principle comes from Vilfredo Pareto, an Italian economist who originally formulated his theory in 1906. You might have also heard of it as being the 80-20 rule, which states that 80% of a problem is attributable to 20% of its causes or inputs. There are different variants on how this rule is actually used. Maybe use it yourself. Once I even heard the claim that 80% of a company's profits very often come from 20% of its customers. The Pareto chart organizes and displays information in order to show the relative importance of various problems or causes of problems. It's a vertical bar chart with items organized in the order from highest to the lowest, relative to a measurable effect, i.e. frequency, cost, or time. Next one is histograms. The histogram is used for showing a probability distribution graphically. The distribution of the collected data would be presented in a graph form. It's also used to show the frequency of certain categories or factors. You might also know this tool as being a bar chart and usually is put in ranges or bins. The design makes them easy to understand, which might be the best attribute for this tool. The next one would be control charts. Control charts are also known as Shewhart charts, after Walter A. Shewhart. Does this name sound familiar? Yes, it's the same Shewhart from Plan, Do, Check, Act. Well, the idea is to determine whether or not a process is stable or has a predictable performance. What we set for the upper and lower specification limits are based on one's requirements. But the general rule states that a process is out of control when 7 consecutive plot points are above or below the mean. And now for our final tool, scatter diagrams. The scatter diagram is used for showing a relationship between 2 factors. Let's call them X and Y, either causation or correlation. This is quite apparent through the slope in the diagram. What kinds of correlations are possible? We either have a proportional correlation, which is positive, or we have an inverse correlation, which is, yes, you guessed it, negative. The last type of correlation is called zero, which means there is no correlation. This ends another video lecture. Thanks for watching.